What's up, y'all? Mr. Kowalczyk here again. Today we're going to do the Pythagorean Theorem, Geometry, Unit 10, Lesson 2. Standard 16.2 says, I can use the Pythagorean Theorem to find a missing side of a triangle. Now, we've been doing the Pythagorean Theorem a little bit this year, so hopefully you can describe it as if you were explaining to someone who had never heard of it before. Pause the video, take a minute, and please go ahead and explain it in such a way. All right, cool. Hopefully you explained it there and in a way that's going to make sense. So we've got our right triangle here with sides A, B, and C, where C is the hypotenuse, right? And A is a leg and B is a leg. And we're going to refer to them that way. Now, the Pythagorean theorem, remember, is A squared plus B squared equals C squared. And that tells me that the distance of A squared plus the distance of B squared is equal to the distance of C squared. So, and over here we have our visual example of what that looks like. So in this case, we've got a three-sided triangle, a leg of a triangle, a four-leg of a triangle, they're right triangles, and then we have our five sides. So if we square this, we get 9, and we square 4, we get 16. That's going to equal 9 plus 16 is going to equal 25 there. So this is a visual way to see how the Pythagorean theorem works. And we can see that here as well. This works only for right triangles. All right, now another way to think about this, if the A and the B, sometimes it's helpful to think about it in terms of one leg squared plus the other leg squared equals the hypotenuse squared. And I've also seen lots of kids work with it in such a way where they take the hypotenuse squared and they subtract one leg squared, and that's going to equal the other leg squared. Yeah. So a couple different ways to think about the Pythagorean theorem. Maybe you've learned those in the past. All right, now how do we use the Pythagorean theorem? In this one, I'm going to do a couple examples with you and let you take care of the rest of them on your own. So in this situation, first off, what I'm going to do is I'm going to label, I've got leg and my hypotenuse. How do I know it's my hypotenuse? Remember, it's across from that right angle. Yeah. Okay, so now I'm going to plug this into what I got back up here. So now I have 4 squared plus x squared equals 6 squared. Okay, now I'm solving for x, so I have to isolate that x. 4 squared is 16. I don't know what x squared is yet. And 36 is going to be 6 squared. Now I get that x isolated by subtracting 16 from both sides. X squared equals 20. Now I'm going to square root both, and the x is going to equal the square root of 20, which from yesterday's lesson, I remember that I can now simplify. So x is going to equal square root of 4 times the square root of 5. Yeah, and then I have 4 is my perfect square, so that x is going to equal 2 times the square root of 5. And we're done. Fantastic. All right, now we've got number 2 here. We have an isosceles triangle because we have 2 legs that are the same. And that's going to split this base in half. So from here to here is going to be 1 unit. And from here to here is going to be 1 unit also, because the whole thing is 2, right? All right, so now what that tells us is that we've got 3 and 3 and x over here. So now what I can do is I can redraw just half of this triangle as the right triangle, where this is x, my dotted line, this side is 1, and my hypotenuse is 3 across from the right angle. All right, so now we know a squared plus b squared equals c squared. So I can plug my values in and see what happens. 1 squared plus x squared equals 3 squared. 1 plus x squared equals 9. Subtract 1 from both sides. X squared equals 8. Square root to get rid of my squared symbol. X is equal to square root of 8, which is equal to square root of 4 times the square root of 2. Square root of 4 is just plain old 2. X equals 2 root 2. Yay. All right, y'all. Now up here it says hint for number 3. How could you split the figure to form a right triangle? All right, well, I got some right angles here. Maybe I draw a line here, but that's not really going to give me a right triangle. Draw it this way. No, that's not going to work. What if I took a line and just dropped it straight down here and created a rectangle right there. That would give me a right triangle right there. This one right here. All right, so now I got to figure out my distances. Well, if this is a rectangle, I know this is 3 because it's opposite that. And this is going to be 6 because it's opposite that side. Opposite sides in a rectangle are going to be congruent. Awesome. So now I got my 6. But what is this? Well, if this whole thing was 10, that leaves me with 7 right there. All right, so this is a little marked up, so I'm going to redraw this so it's not as confusing for me. So now I got 7 and 6 and x right here. All right, so now my hypotenuse is across. I'm going to label that hypotenuse, that's that side. Now we're going to consider this the c squared side. So then I'm going to get 6 squared plus 7 squared, because those are my legs, equals c squared. All right, let's get her done. 36 plus 49 equals c squared. 36 plus 49 is going to give me 85, and that equals c squared. Okay, so then I square root both sides, and then square root of 85 equals c squared. Now, square root of 85, I can't simplify, believe it or not, because it goes into 5, but if I divide it by 5, 85 by 5, or 5 goes into 85, I should say, we get 1 with 3 left over, and that's 7. So 5 and 17 would be my factors if I split it up. But there's no pairs, and they're both prime. So I can't actually split up square root of 85 and simplify it anymore. So that's my answer. Not c squared, sorry. C just equals 85. We're done. All right, let's do one word problem, and then we'll call this video done. Number 4, I like this problem a lot. Number 4 says the Hubble Space Telescope, which is a space telescope that's out in space. And it's a space telescope, I guess, that makes sense. So its orbit 600 kilometers above the Earth's surface. So from the Earth's surface above to where the telescope is, that's 600 kilometers right there. The average radius of the Earth is 6,370 kilometers. So that's the radius right there, from the center of the Earth all the way out to the crust or the edge. Use Pythagorean theorem to find the distance x from the telescope to Earth's horizon. So that's this distance right here, the horizon to the telescope. That's what we're trying to solve for. Round your answer to the nearest kilometer. So that'll be like the nearest whole number. All right, so let's redraw a triangle over here so we can see it a little better. So the circle isn't in the way. Not so good. We got a right angle here. We know this is x. We know this side is 6,370. Now, the problem is over here, we don't know what this is to this is because it's not labeled. But yay, actually we do know, because from here out to there is the same distance as from here out to there, because it's a radius of the Earth. So this distance from here to here is also 6,370. So if we add these two together, we'll get the total distance from the center of the Earth out to this telescope, which is also our hypotenuse, opposite the right angle. So 6,370 plus 600, 0, 7, 6 plus 3 is 9, 6. That gives us 6970. That's our hypotenuse. Awesome. Okay, so now we got to set up our Pythagorean theorem, where we have leg squared plus leg squared equals hypotenuse squared. And again, that hypotenuse is across from that right angle. All right, so 6970 squared. We're going to get some big numbers here. And then we have x squared over here plus 6370, which are our two legs. All right, now I got my calculator. I'm all set to work this out. And did this problem ahead of time, so I got the numbers all set here. So we got 6970 squared is 485,80900. So I'm going to make my commas, comma there, comma there. That's 48,580,900,000. And then 6370 squared is going to give me that x squared way over here, plus 405,76900, comma, 40,576,900. Now we got to subtract 40,576,900 from both sides. I know the numbers are big, but the process is still the same. Okay, so that's going to give us 8,004,000. So that's 8,004,000 equals x squared, because that's all we're left with over here. Okay, that's an 8, doesn't look like an 8. Now we take the square root of both, and we put it in our calculator, and that gives us the distance of x is approximately, and as soon as we approximate, remember, we got to put that squiggly sign in there, because it means about 2,829 kilometers away from the center, from the horizon to the telescope. And that's how we sort that one out. All right, I'm going to let you play with the rest of these. Some of them are multi-step problems where you got to do 2 Pythagorean theorems, like number 6. You got to figure out this distance here, and then you're going to figure out the hypotenuse over here in order to figure those out. But I'm sure that you can do it in class when we see you next. All right, have a great one. Okay, scratch that. We're actually going to keep going. I forgot that there were some notes on the top of the next page. All right, the numbers in problem 8 are an example of a Pythagorean triple. So let's take a look at number 8 here. We got this one right here, 13, 12, and x. So let's go ahead and solve that one, and then we're going to figure out the Pythagorean triple. So in this case, we got 12 squared plus x squared equals 13 squared. So that's going to give us 144 plus x squared equals 169. Subtract 144 from both sides. That's going to give us x squared equals 25. We square root both of those, and then x is going to equal 5. So we know that this equals 5. So these are called Pythagorean triples. So now what a Pythagorean triple is it's a set of whole, rational numbers. And what I mean by rational is something, in this case, that's non-radical and non-repeating. Basically like a whole number that's not in a radical sign. Okay, so what are some examples? Well, let me give you some. We've got 3 squared plus 4 squared equals 5 squared, like that example from the beginning of the lesson where we had that 3, 4, 5 triangle. Yeah, and then that's 4. We've got another one that we just saw on the previous problem, which was 12 squared plus 5 squared equals 13 squared. And they work out. So we have 9 plus 16 equals 25, as we saw, and that's true. And then we have 144 plus 25 equals 169, and that's true also. A non-example, that would be something different, where we don't have whole numbers that give us, that make the Pythagorean theorem true. Like something like this, where we had, let's say we had 4 squared plus 8 root 2 squared equals 12 squared. Now, as soon as we see this radical in here, it goes against this. So that this is no longer Pythagorean triple, right? Even though 16 plus 8 root 2 squared, excuse me, is going to give me 8 squared is 64, and then root 2 squared is 2, so that's 128 equals 144. And if we add these two together, we get 144 equals 144. So that's a non-example. It's true, but it's not a whole rational number, so it's not a Pythagorean triple. Another one would be 6 squared equals 4 squared plus 2 root 5 squared. All right, so this is 36 equals 4 squared is 16 plus 2 times 2 is 4, root 5 times root 5 is 5, 4 times 5 is 20. 36 equals 36. Now, even though these three numbers make a right triangle, for sure, it doesn't necessarily, it doesn't fit the definition of the Pythagorean triple because this is not a whole rational number. Now, the next thing that we want to look at here is, I'm going to ask you to do this and pause the video for just a quick sec. Pick one of the examples of Pythagorean triple above, like these two. Multiply each number in the triple by a number of your choosing. All right, so let's pick 12, 5, and 13. So we'll say 12, 5, and 13. And I'm going to choose 3. That's the number I'm choosing. Now I'm going to multiply each of these. 3 times 12 is 36. 5 times 3 is 15. And 13 times 3 is 39. Okay. Now, because this is my longest, I'm going to plug it in and say 36 squared plus 15 squared equals 36 squared. Does that work out? All right, well, let's get our calculator out here and see if that's actually true. So 36 squared, clear, 36 times 36 equals 1,296 plus 15 squared. I know that one, that's 225. Does that equal 39 squared? 1,521. Well, let's add those two together. 1,296 plus 225. Sure enough, 1,521 equals 1,521. So if you take a Pythagorean triple and you multiply it by any whole number, right? And then you do that Pythagorean theorem, just like we did right here, it will make it true. So you're just making the Pythagorean triple bigger by a factor of 3 or 4, whatever number you choose. All right, I'd like you to do one more of those over here on your own. Follow these same 3 steps, okay? And then that'll be it for today. But I did want to talk about Pythagorean triples. I apologize for saying we were done and then jumping in for another 3 or 4 minutes. Now I'm done. Have a great night. We'll see you next time.